our last video for Chapter F, we will be focusing on Section 3.4 out of the book, which focuses on parallel lines, which we've been discussing the whole chapter, but how this kind of comes into effect with triangles. So first, some very, hopefully, review here, that we can classify triangles by two different things, by their angle measurements and by their side lengths. So hopefully these four terms look familiar, that you could tell me what they are. This isn't going to be a big thing, but it's nice to know that you know these terms. So acute just means that all three angles of the triangle, now we're not just talking about one acute angle, we're talking about an acute triangle. So an acute triangle is where all three angles are less than 90 degrees. An obtuse triangle, obtuse angle was just an angle larger than 90. An obtuse triangle is just one angle is greater than 90. A right triangle, which we've dealt with previously with trig and the Pythagorean theorem, was when we had a triangle that had exactly one 90-degree angle. And equiangular just meant that all three of our angles were of equal angles, aka that they were 60 degrees. Okay? So again, these four things are in reference to the type of triangle they are, not just a type of angle. So an acute triangle, obtuse triangle, right triangle, and equiangular triangle. Then by side lengths, hopefully these are much more familiar than the last four, but a scalene triangle has no sides that are congruent. They're all different values. Isosceles was two sides that are congruent. And equilateral just meant that all three sides were congruent. Okay? I know sometimes some of you get isosceles and scalene mixed around. I can't really tell you a nice easy way to remember which one's which. I just always remember that isosceles is 2 for whatever reason. All right, now the main thing we're going to discuss. How many degrees make up the three angles inside any triangle? Well, angles 1, 2, and 3 always have to add up to be 180 degrees. But have you ever asked yourself, why do the three angles of a triangle have to add up to be 180 degrees? Some of you might think, oh, well, this is a postulate. Well, you know, this is the smallest shape we can technically draw, and so why don't we just say it has 180 degrees, and every other bigger shape, like a 4-sided and a 5-sided and 6-sided, it's all based on this 180, which is based on the small triangle. So maybe, you know, like squares and pentagons and hexagons, they're more theorems because we have to prove their existence, but triangles we can't really question, so maybe it's a postulate. But it's not. There's a reason why there's 180 degrees in a triangle. And that's what we're going to look at first in this video, is a proof of why there's 180 degrees in any triangle. Okay? There's some things in this proof that you wouldn't normally think of doing, which is kind of the first thing we're going to do here, but hopefully by the end it'll make sense. And everything that we've talked about so far in this chapter will tie into it and hopefully really make sense. Okay? So our given information, if you will, in this theorem that the sum of the three angles of a triangle is 180 degrees is, well, nothing really. Nothing's really given that we have to write out, just that we have a triangle, if you will. So I'm not really going to have any given information, if you will. The first thing I need to do is I need to draw a line like so. A line that just touches this point up here, different color, that touches the very top of this triangle, and I want it to be parallel to the bottom of this triangle. Okay? So I'm going to call this, line A. Okay? And I'm going to call this down here, you know, think about this line extending out, if you will. Oop, that was bad. Let's redo this. That's still really bad. I suck at drawing lines. All right, let's just get my line cheater tool here. Boom, almost boom, it's above. I know you're laughing. It's okay. There, parallel. Okay. Anyway, I got my marks here that say they're parallel anyway. So, nah. All right, let's call this line B. So first, I guess you could say my given information would be this. A is parallel to B. There's my given information. I want that to happen. I need that to happen. So I create it to happen. Okay? I can create parallel lines. Now, what we need to start looking at here are some types of angles, some special angles that we have discussed so far this chapter. And so what I might look at is, let's say this as a transversal. And let's pick on angle B down here. Now angle B, I want to somehow talk about angle B up here somewhere. And so I'm going to pick on its alternate interior angle, which would be right here. And this angle B and this angle B are the same. They're alternate interior because I have parallel lines. So this angle up here is a B, just like that angle B. Likewise, I can accomplish the same thing with angle C if I look at this other line as a transversal. And if I go, all right, here's one angle, here's its alternate interior. Okay, and because I have parallel lines, they are congruent. All right, so in my proof here, this is kind of tough. How am I going to do this? Let's take away those things for now. We know that's going to happen, but let's call this angle 1 and angle 2. Okay, so now I'm going to come along and say angle 1 is equal to, let's call it angle B. Why do we know that's true? The alternate interior angles theorem. Angle 2 is equal to angle C. Why? Same reason. They're alternate interior angles, and that theorem says that they must be congruent because we have parallel lines. So now, if I look at all these things up here, what's true about angles 1A and 2 together? Well, together they make up line A, and a line, aka an angle, has 180 degrees. So we can say angle 1 plus angle A plus angle 2, they all equal 180 degrees. And why is that true? The straight angle postulate. So I know that 1A and 2 equal 180. My ultimate goal here, again, remember, is to show that A, B, and C equal 180. Well, I've got this 1 and this 2 in the way. I've got the A taken care of here. If there was only some way I could get rid of angle 1 and replace it with something else of equal value. Oh yeah, like B. So instead of saying angle 1, I'm going to swap it out with an angle B. I want to keep A. I don't want 2, so I'm going to swap it out with C here. So here I'm using the substitution property. And I am done. I just showed that angles A, B, and C in that triangle have to, in fact, add up to be 180 degrees. And it's all based on the fact on alternate interior angles and the straight angle postulate is why triangles have 180 degrees, which is why we had to prove it, because it's really, in fact, a theorem. Okay? Would I expect you guys to come up with this proof all on your own? Absolutely not. But the more you see different proofs being done, the more ideas you get into your head of what you can or maybe cannot do in a proof. Okay? So you won't have to do this proof on a quiz or a test. Don't worry about it. But hopefully it makes sense now why a triangle has 180 degrees. I had always wished when I was in high school that my teacher had showed me this proof of why triangles have 180 degrees. One more theorem we're going to look at and prove is called the Triangle Exterior Angle Theorem, or I sometimes refer to it as the Remote Interior Angles Theorem. Okay? There are 3 specific angles we're going to look at. Okay? There's an exterior angle. Basically, if you were to take one side of a triangle and make it go past where it should really go, we get this angle formed out here, and it's an exterior angle. Okay? I could make this line go past where it needs to go, and then this would be an exterior angle. And I could, continue to make this line go, and there's an exterior angle. I can make that line go, and that's an exterior angle. There's lots of exterior angles. There's 6 to any triangle. What I want to show is that this one exterior angle is equal in value to the sum of these things called remote interior angles. Remote interior angles, there's always a pair of them, and here's an easy way to remember how to locate them, is that they are not connected, they are not adjacent to this exterior angle. Angle C in this triangle is adjacent to the exterior angle, so it's not one of the 2 remote interior angles. It must be the other 2 angles. So if we were to add together angles A and B in this problem, because they are our remote interior angles, that they are the same thing as the exterior angle on the other side of the triangle. That's what we're going to prove is true. So again, we want to prove that A and B make D. Okay? So here we go. What's our given information? Nothing really. I mean, we've got a triangle and we've got an exterior angle there. There's nothing really we can write. So what can we say is definitely true in this picture? Well, we just talked about what the three angles of a triangle add up to be, right? We know the angles A, B, and C add up to be 180, and that was called the Triangle Angle Sum Theorem. You're not going to need to know this one, trust me, okay? Just, you won't have a proof where there will be the triangle angle sum theorem will be a reason that you'll have to use, okay? It's just going to be for this proof. All right, so we know these three angles add up to be 180. Sweet. What else is going on in this picture that's true? Because typically in a proof, we need at least two pieces of information to combine them together to talk about something new. Well, you might go, well, C and D together, hey, they make a straight line, straight angle, so they add up to be 180. True. Angle C plus angle D equals 180. Thank you, straight angle postulate. You're welcome. Here's our two pieces of information now. Okay? Keep in mind what the goal is here. We want to show that A and B equal D. So, with our two pieces of information, they are both equal to 180. Therefore, they're equal to each other. Okay? So A, B, and C, the three angles of our triangle, are the same thing as C and D, because they both equal 180. This is 180, this is 180. Okay. So we just used the transitive property of equality. Again, I want to show A plus B equals D. I've almost got it, except I've got that pesky angle C. But you know what? I've got angle C on both sides. So if I were to subtract angle C on both sides, that would be a significant help, because then I would have exactly what I needed to show was true. Okay? So we use the triangle angle sum theorem, the fact that triangles have 180 degrees, plus the fact that an exterior angle with its adjacent interior angle over here with the straight angle postulate make 180 degrees. We made some transitive property relations here. We subtracted out what they had in common. What's left is what we wanted to show was true. All right, the rest of this is just going to be actual examples. So on 1, we want to calculate each unknown angle. Well, let's see. I've got a triangle, adds up to be 180. I only know one angle though, 70. I can't figure out A and B at the same time. But one thing I do notice is that A and 120 together, straight angle postulate. So 180 minus 120 is going to give me angle A, which is 60. So angle A is 60. All right, well now looking in the triangle, 70 and 60 make 130 degrees. So now if I subtract 180 from 130, that leaves me with B being 50 degrees. One thing I want you to take a look at and notice is that remote exterior angle theorem, the one we just proved back here. Notice how it's working. Well, if I can get the right page here. There we go. That it's really working in this problem. Here's our two remote interior angles, 70 in the B, which is officially 50. 70 and 50 make 120. And there's that exterior angle 120. Works out. So to begin with, we could have started with B, if you think about it, because we could have said the sum of our two remote interior angles is equal to the exterior. B is 50. And then we could have concluded that A was 60. Now we get into a fun one. Example 2. How many triangles are there in this problem? Well, at first glance, you might go, I don't know, 1, 2, but there are in fact 3. We've got this guy over here, we've got this guy over here, and we've got technically where they overlap. Each one of those triangles contains 180 degrees. So we need to find 3 things, W, X, and Y. Okay? If I try focusing on this little triangle, I only know one angle in it. I don't know X and Y. Can't start there. Well, what if I started on this first left big triangle here? Where are my 3 angles of this triangle? the 55, the 90, and the y. The 25 and the x are just kind of floating inside this triangle. It has nothing to do with the 180 degrees, so we just ignore them. So 90 and 55 and y should make 180 degrees in this triangle. We've got 145 degrees accounted for, which means y must be 35 degrees. We could do x now, because now we know two of our three angles in the overlapped triangle here. So we could say, color, the 35 and the 25 plus x equals 180. We've got 60 degrees really accounted for. So x must be 120 degrees. Okay. Now w. W, we're going to want to look at the big triangle on the right. And what are its three angles? The 25 makes up this angle, the 120 up here, and the W over here. This 120 and this 35 really aren't any of the three angles of the triangle. It's just kind of floating around inside. We ignore it. Scooch this over. There we go. So now we've got the 120, the 25, and the W make 180. We've got 145 degrees accounted for, which makes W 35 degrees. Now, an extra thing I want to point out that maybe you've noticed by now, we'll see, is the interesting fact that y and w are the same value. They're both 35 degrees. And you might go, you know what, who cares? Well, what if I were to point out this? That line with this line and this line. And if you were to ignore everything else in this problem, ignore this line, ignore this, what type of angles are W and Y? They're corresponding angles. What's true about these corresponding angles? They're congruent. If we have congruent corresponding angles, therefore we may conclude we've got some parallel lines. So just one little side extra thing here is that technically these two sides are parallel. Is it true that these two sides are parallel? Well, here's these corresponding angles. Are they equal? Nope. No parallel lines there and there. All right, the last problem we're going to do together is example 3. It says the measures of three angles in a triangle are given. Calculate x and classify the triangle by its angles. So this represents one angle, two angles, three angles. What do we know about the three angles of a triangle? Well, they add up to equal 180. Okay, so 20x, 30x, plus 7x all makes 57x. Constants, plus 10 minus 2 plus 1. Well, 10 minus 2 is 8, plus 1 makes 9. Equals 180. We'll subtract that 180, subtract the 9 over, and we'll get 171, and x is 3. So part 1 done. Calculate x. Now classify the triangle by its angles. Okay, we know what x is. Let's go back and plug in 3 into x. So this is 3, this is 3, that's 3. Let's see, 20 times 3 is 60, plus 10. This is really a 70-degree angle. 3 times 30 is 90, minus 2 is 88. 7 times 3 is 21, plus 1 is 22. So here's our three angles, all three of which are less than 90 degrees, meaning this is an acute triangle, since all three angles are less than 90. This is the type of explanation I'm looking for, where you say this is the answer because or since what reason? What did you see in the numbers that would help verify that your answer is really the correct answer? All right, I want you to try the next one, which is just like the one we just did, and then I want you to finish out and do example 4. and figure out what are the values of w, x, y, and z. And notice in this problem that we do have parallel lines, so you may use some of those special angles that are formed by parallel lines. So we'll talk about those two problems in class the next day, and we will see you tomorrow.